This is a Bruning Zeta 8A pin plotter from the 1980s, and this might come as a bit of a surprise. I have never used a pin plotter in my life. So I want to fix that right here, right now. And my buddy Mike hooked me up with this particular plotter, and it looks to be in excellent shape. But I can already tell that we're going to have a massive problem that I don't really know how to overcome, and that has to do with paper. But, well, I think in order to show you guys that exact problem, it's going to make more sense to get the top off of this. On the front of the plotter here, we have this control panel with a bunch of status LEDs on it, and these are just the worst buttons ever. Like, I can't tell what's a button and what isn't. It just all feels flat with zero feedback whatsoever. On the left side of the plotter over here, we have a little door that's held on with some magnets, and you just pull that away and you get access to a bunch of dip switches in here. And looking through the manual, which thankfully I was able to find on eBay, these switches appear to be set up for mode 6, which is HPGL on RS-232, to act as an HP7475A with software handshaking, set up for 9600 baud, no parity, and then 30% speed with maximum pin pressure. And then on the back of the plotter, we have a RS-232 plug here that says to modem and another one that says to terminal, and that's because it was quite common to have a printer hooked up in series with your data terminal, but really we only care about this one that says to modem here. So that's going to go to our computer, and that's what's going to send our HPGL files over so that it can print out. We also have these little, I don't know, hooks is what you're going to call them, that would hook into a roll of paper that then went back up into here. But I don't have that roll of paper, which is the problem that I was talking about earlier. To get the top off, there are two screws that go through the bottom piece into the top piece that are right next to these little hook things here. And you just got to remove those, and whoop, that one came right out. And then on the front, there are two more in the far corners here that are in very deep pockets. Let's see if I can even get on there. There we go. And with those removed, there it goes. With those removed, the top should come right off. And here we go. Yep, lift straight up. All right, looks like we've got a ribbon cable connected here that is not a plug on this side. I have no idea where that goes. Oh, this has gotten awkward. Oh no. All right, that's just gonna have to stay connected like that for now, I guess. I ended up just unscrewing this little front control panel here from the outer case, and that allows me to just kind of get this out of the way. And now we've got pretty good look at everything that's going on here, and it's surprisingly simple, but also surprisingly complex from an electrical standpoint. Like, mechanically, you've just got X and then Y, and that's it. And Y is just a really big platen here with tractor feed nubs on the side, and X is very stiff. So we're gonna have to loosen everything up. I can see a lot of surface rust right along here on the rail that it's supposed to slide on. So we're gonna have to clean that up as well. But electrically, there's a circuit board in this thing that like covers the entire width. It's huge, and I can't really see much of it. The only way that we could get to the circuit board is to remove all of this, and I don't particularly want to do that. So for the time being, I'm going with the innocent until proven guilty troubleshooting method here, and so I'm just going to assume that everything works. It's just dirty and needs a little bit of cleanup. But even then, there are still two problems that we're going to have to tackle. And the first is paper. You can see that the primary roller here has these little tractor feed nubs on the edge. So you need paper that is the correct width to engage with those tractor feed nubs. This piece of paper right here is a standard 8.5 by 11 sheet of paper. The tractor feed nubs add a 1/2 inch on either side, so the total width comes out to 9.5 inches. And you can see that it is nowhere near wide enough. Now, they do sell versions of this that are landscape, that put it this direction essentially. So the tractor feed is on the left and right side. However, if I were to line this up as if though it were one of those two pieces of paper, you can see it's still too short. But if we step up to the next most common size sheet of paper, like this green bar here, which is 14 inches plus the 1/2 inch tractor feeds that makes it 15 inches, we are now way too wide. And I searched and searched and searched and could not find any piece of paper that was 12 inches wide, but 13 with the tractor feed nubs on it. So I have no idea what we're gonna do for paper. I mean, I suppose you could load it up and just engage one edge here, but I feel like that's gonna end up with the paper doing a lot of, you know, wibbling around like that. But I don't know, maybe the pressure on the pin isn't so much that that's going to be an issue. That's clearly going to be an issue. That's not going to work right at all. Oh man, so I don't know what we're gonna do about paper, and already I've got things jammed and stuck. But the next problem is up here with the pins. This little pin holder is a pretty interesting design. First of all, it just pops out nice and easy like that. So maybe you can swap entire pin holders, or I don't know. It looks like it holds up to 8 pins, but there's currently only 3 pins in it. This little solenoid on the top here is what's gonna control the amount of pin pressure. That pushes a pin down. Now the pins themselves look like they're just like regular pins, but they have these extra little rubber things on the end. So one on the butt and then one around the pin head there. And you can see that these are clearly split around the pin head, and that's going to cause a bit of a problem because this little rubber nubbin here has to slide down into the slot on the very bottom here, which is spring loaded. And with the rubber being split around the tip here, it's not engaging with the spring loaded bit down there, and it's not retracting or going down. And that's gonna be a huge problem that we're gonna have to solve. But first things first, let's get this thing cleaner. It's in pretty excellent shape and was stored in a good environment, but it's probably been 35 years since it was last used, so it's definitely accumulated some dust. I'll use the air compressor to get the light stuff out of there, and then I'll go over it with some simple green and rags. After that, let's get to work freeing up the x-axis. A Scotch-Brite Scrubby does an excellent job at knocking off surface rust without damaging the surface below. Then I'll go through and put some oil on all the bearings. I just want this stuff to John Wick in as best as it can so the bearings can start to loosen up. Working the whole thing back and forth, it does start to break free, and eventually everything loosens up and I can get it moving the full range of motion without any problems. Now to deal with that pin issue. I think the solution here is going to be a little 3D printing. After grabbing some measurements, I need to make a 3D model, and man, I've been waffling about a good CAD program for years, but my buddy Corey talked me into giving OpenSCAD a shot, or OpenSCAD? I don't know how you pronounce it, but you know what? I really like it. Granted, this was a pretty simple thing to model, but it only took like 6 lines of code in less than 5 minutes. I'll fire up the Ender 3 my buddy Nick hooked me up with. Thank you so much for that, Nick. And you know what? Actually, I'm gonna go off topic here for a second. Nick does some amazing astrophotography, and I happen to have a really, really nice infrared spectrometer. So one of these days, we're going to combine our powers and get some top tier stellar spectra. Total tangent, but I'm super looking forward to that, Nick. It's gonna be a ton of fun. At any rate, the 3D printer seems to be doing its thing, but I'm getting these weird strings between parts. I have no clue why that's happening. This is like only the 3rd thing I've ever tried to 3D print. So if you know what's up, chime in and I'll adjust my workflow. But it was easy enough to clean it up with a razor blade afterwards. The holders that I was just 3D printing look a little different than the original rubber pieces over here, which you can see that massive split very clearly right there. The problem that I was running into is that this skinnier part on the top is incredibly thin. It's like less than 1 millimeter thick. And I just could not get the 3D printer to print something that thin. I made a ton of different prototypes. This one looks quite nice, but it's still way too thick and ends up binding up in the pin holder. And ultimately, I don't think that this long skinny part is actually all that necessary. And that has to do with the construction of the spring-loaded base of our pin holder here. And you can see that there's 8 little holes down here, and each one has a smaller ring inside of the hole that is spring-loaded. And if I take one of my pins here and I slot it in, you can see the skinny part goes through the center of that hole, is supposed to. This one doesn't because it's split. That was the ultimate problem with these. And then the spring is That's just not gonna work. So we'll move over to one of the ones that I 3D printed here. It goes into there, and then the spring pushes up on the fat part of the new pin holder that I've 3D printed up here. The little lip here is important so that the pin itself centers on that opening on the spring-loaded cup there. And you can see that down here there is another cup inside of the hole that has a smaller diameter. So when the pin comes through, we'll use one of my new ones here. When it comes through and it's being pushed down on the paper, you can see that the pin itself has a much smaller diameter than that hole. So I think the point of the tall rubber piece here was to properly fill out that hole and hold the pin very rigidly. But like I can't get my 3D printer to properly print something with that thin of a wall. Either I don't have the skills or the 3D printer doesn't have the skills. So instead we're just gonna use these shorty guys, and you know what, I think that that little tiny bit of movement is not gonna be that vital. So we'll see how it works. Now the green and red pins actually totally came back to life, so they're still totally usable, but the black pin here is very, very, very dead. So I'm gonna need to try and figure out where to get proper replacements for these. I can probably just use a modern ballpoint pen as long as it has a similar shape, and then I can make a new design for my little spacers here to fit those ballpoint pens. But for the time being, we're just gonna rock green and red. Now, I have absolutely no idea if this thing will actually power up. I've just been focusing on trying to get the mechanical side of things moving smoothly, which, you know, they seem to be doing so right now, but I've never actually put power into this thing, and there could very much so be some kind of digital logic fault. So let's flip the power switch and see if we get some LEDs on the front here. So here goes nothing. No LEDs on the front panel here. I don't think anything has powered up. Oh! Well, earlier I said that my troubleshooting method is innocent until proven guilty, and it has now been proven guilty. Also, I didn't realize how easy it was to open this thing up. It's just 2 screws on the front corners here, and then the whole thing lifts open, and you have very good access to absolutely everything. The motherboard here has a boatload of ROMs on it. I should probably dump those at some point in time. But also there are 2 8088 processors, one back here and one up here, both built by AMD. And we have a boatload of Intel 8255 IO chips. I mean, this is a pretty cool dual processor motherboard for the thing. And then up here on the underside of the plotter itself is this board, which has looks like a boatload of analog and power control stuff on it for driving the big honkin' stepper motors down here. So my guess is that all the digital logic is done on the motherboard, and it sends control signals to this that then create the correct stepper signals for the motors. And then there's also, I can see a little wire here that comes back for X and Y that are probably resolvers that have all sorts of positional information on here. And finally, down here on the right side is the main power supply, and this is likely where our problems are originating from. These big caps are probably fine, but these little guys might be a bit of an issue. Also, there's a bunch of tantalum capacitors all over this thing, so any one of those could have shorted at some point, and that's what's holding us back. And before I even got the multimeter out, I already noticed something horrifically wrong. I was trying to remove this ribbon cable that goes to our servo control board up here, and you can see a mouse or something has been in here, because that is a fully cut through and missing pin 1 of this ribbon cable, and I think pin 2, this ribbon cable is trash, garbage. Which absolutely could be causing the problems that we're seeing, but also it brings into question all of the other probably quite delicate wiring in here. I need to go through and double check all of that before we try to send it again. And of course we do indeed have a bad tantalum somewhere. I was just going through with the multimeter and checking for resistance across various random tantalums, because I thought that would put me on different voltage rails. And check this one out right here. So I'll see if I can do this without blocking the multimeter for you guys, or knocking it over apparently. So there we go. That particular voltage rail is at 0.4 ohms. So yeah, we have a tantalum on that rail that is fully shorted. Whether it's that specific tantalum or not, I don't know yet, but we do have one of the voltage rails completely and totally shorted out. And I think I've tracked it down to this specific tantalum right here. After I disconnected the power cables that go into these giant plugs on both the motherboard and this analog board here, that isolated both of the boards from each other, and the motherboard actually doesn't have any shorts on it anywhere. But this tantalum is measuring shorted. All the other tantalums actually measure totally fine, which means that they're on different power rails. And it just so happens that this tantalum and the one on the motherboard were on the same power rail. I've got it out. It's just a little 22 microfarad, 16 volt cap here. And if I put my little probes on it, you can see right there 0.4 ohms, 0.3 ohms. That cap is dead shorted. That's a pretty common size. I'll just go ahead and pop a new one in. And there it is, a little 33 microfarad electrolytic, just because that was what I had hanging around. It's a bit bigger than the other one, but I think that's just, it's gonna be totally fine. And here's a new 40 pin ribbon cable to replace the one that the mice had gotten to. This one is way too long, but whatever, it'll work. Also, it came out of a deck machine. You can see it says digital right there. So we're just gonna kind of, I don't know, coil this thing up a little bit and get it into place here properly. All right, here we go. Let's try again. See if anything changed. Yes! A lot of stuff changed for sure. This is fantastic news. You can see that we have our power light, first of all. That's a huge plus. We have data terminal ready. We don't have anything plugged into it right now, so we don't have like a data carrier detect. There are no errors, and we're not receiving any data. We haven't hit a limit switch, so that's all pretty good. Shows that we've selected pin 1 out of 8. I think this thing is now mostly functional. Most printers and plotters have a self-test plot or print that they can do to let you know that things are working without having to plug them into a computer. And this Zeta 8 is no different. We have this traveling square plot here that we can test by setting the switch settings to what they outline here. So it says to flip all the switches on 0, 1 here down, and I'll just go through and get all 8 of those. And then it says, ooh, I missed that last one. And then it says to switch 2 and 3 up all the way. So I'm just gonna go through and flip all of these up. Don't worry, I took a picture of all of these settings before I started changing anything, so I can actually return it back to the settings that it was in originally. And, oh, come on. There we go. There's the last one. And then finally it says to set the 2 rotation dials to 5, 5. So that one should go to 5. And that one should go to 5. All right, now when we power it up, it should print that square pattern. All right, I've just got a piece of 8.5 by 11 hooked on just one side. I am not expecting this to go well, but this is just an alive or dead test. So let's flip the switch. Well, what happened? Now it's not turning on at all. What the heck? My front panel is totally dead again. All right, there we go. It's doing something. All I did was power cycle it. So I have no idea. We still have some power delivery issues apparently. But it looks like it's going back and forth on a bunch of pins that I don't have installed. There's pin 1, but now it's on pin 4, pin 3, pin 5, 6. So, oh, I don't know what that's about, but the paper does seem to be going back and forth quite well. I think what we need to do now is, instead of the test pattern, we need to just send it like something real. So let's send it an HPGL file. I've got a couple of random HPGL files I found online. No clue what's on these, but one of them is called test. So I'll go ahead and send this and see what it does. Okay, it drew something, but it drew it. Okay. We hit a limit fault, but I was able to send it something. How cool is that? Let's do a clear maybe? Okay, that brought this back to home. I think these are meant for a different plotter where the limits are slightly different. That's not great. Let's try, just keep trying different ones. Maybe we'll get lucky on here. So this is. Oh, it's drawn on flattened. All right, that's doing stuff. Okay, I think this is proof positive that we can send it files. That's pretty epic. I gotta figure out the paper problem because this is a big issue. Hey there, Future David here. I'm jumping in here because this like filming went way off the rails. I messed around with trying to get paper to work in this thing for like 3 hours, and the answer was actually surprisingly simple. I just took the 14-inch green bar paper that I have and just cut one side of it off at the right length. I think I cut it at about 12¼ inches here. Pretty much it's wide enough to come right up next to the nubbins on this side, but not actually touch them. And I was very worried about the paper slipping and sliding around, but it turns out that the biscuit fan that's on the bottom here actually pulls air in through these openings around the platen. And that creates a suction that pulls the paper down and holds it very rigidly in place. So that way you can get away with having tractor feeds on just one side. Really brilliant way to do that, but also the proper way to do this is to get a roll of paper that is the correct width with tractor feeds on both sides. But I cannot find that for the life of me. So in the meantime, I'm gonna keep using this. I think it'll work all right for now, but hopefully someday we can find the correct paper for this thing. Two more things right quick. The ROMs have all been dumped. I've got them backed up, and the Zeta 8 manual here has also been fully scanned. Now, this doesn't have any schematics in it, but if you have a Zeta 8, this thing is indispensable because it's got all of the dip switch settings, all of the information about how to get the thing set up correctly. And well, I have a PDF of this, so if you have a Zeta 8 or a derivative that is similar, hit me up on the Discord. I'll be happy to hook you up with the ROMs, happy to hook you up with the PDF of the manual. I would love to get these backed up on archive.org or somewhere. I don't really know where a good place to do that is or how to do that. So if you know a good place to back the ROMs and the PDF for the manual up, hit me up on the Discord. I'll hook you up with the files and we can get those backed up. All right, back to past David. All right, I think I figured out most of the quirks. I'm using a different file, and I had to turn on hardware flow control, which is gonna cause problems sometime in the future. But check this out. If I go ahead and hit return on this, it's off to the races. Oh, how cool is that? You guys, you gotta hear this thing. It is ridiculous sounding. So what did we plot? Or rather, what is it plotting again right now? Well, it's the Space Shuttle Columbia. This is the entire reason that I wanted to undertake this project. I wanted to plot out this like absolutely epic design that's from the very early days of AutoCAD. It's beautiful. Now we do still have a couple of big problems. I never figured out what was going on with the power supply. It seems to be getting a little bit better. I haven't had to power cycle it for the last like 5 or 6 times that I've turned it on and off while filming with it. So hopefully the power supply is sorting itself. Maybe those big caps needed to be reformed in place, and they've done that now. But the paper, man, I have no idea what we're gonna do about the paper. Ideally, you're supposed to have a roll that sits in the back with tractor feeds on both sides that is exactly 13 inches, or I think actually a little less than 13 inches across, that fits those tractor feed nubbins on there, but I cannot for the life of me find any of those. So if any of you guys know where to find one of those rolls that I can get hooked up to this, leave a comment, let me know. Otherwise, if you have never played with a pin plotter on a vintage computer, absolutely do it. And granted, I'm going through a laptop, but ultimately this is gonna get hooked up to a PDP 1173, and plotting stuff out on a pin plotter has gotta be in the top 5 of the most hilariously fun things I've ever done with vintage computers. This is absolutely epic. So I want to thank you all so much for hanging out with me today, and I hope to see you in the next one.